Welcome to Math with Miss Garrity. One way to determine whether a set of data can be modeled best by linear or quadratic is to look at first and second differences. Also, if neither linear nor quadratic works, we could look for a constant ratio, and then that would maybe lead us to think exponential function would be the best way to model the data. So let's look at some examples and see what I mean by first and second differences. The first difference is what we've done in the past to find a constant rate of change or a constant difference. So what I'm going to do is I notice that my x values increase each by 1. So I can easily just look at the first differences to see if this is linear. What is 0 minus -1? It's 1. What is 4 minus 0? What is 11 minus 4? And what is 21 minus 11? The first differences show us that this data is not linear. So what we can do now is we can look at the second differences, which is the difference between the first differences. What's the difference between 4 and 1? What's 4 minus 1? 3. What's 7 minus 4? 3. What's 10 minus 7? 3. Notice that the second differences are all 3. When the second differences are constant, it is a quadratic model that would best fit. Let's try another example. It's another set of data. The first difference between the y values, and again, I can look at the first difference of the y values because my x's are going up by a constant pattern of 1, 1, 1, 1. So -2 minus 2 is -4. -14 minus -2 is -12. -34 minus -14 is -20. And -62 minus -34, what would that be? -28. Okay, so it's not linear because the first differences are not the same. There is no constant difference. But now let's look at the difference between the first differences. -12 minus -4 is -8. -20 minus -12, -8. -28 minus -20 is -8. So this also can be modeled with a quadratic function. So when the second differences are constant, we can model the data with a quadratic function. Okay, I have another example. Let's find the first difference. 100 minus 400 is -300. 25 minus 100 is -75. So right away, I know that this is not going to be linear. The difference between 6.25 and 25 is -18.75. So it's not linear. Now I'm going to look at the second difference. -75 minus -300, 225. negative 18.75 minus negative 75 is 56.25. So even just with these two data points, I realize these are not very close. So I do not think this is linear or quadratic. So that takes me back. I'm going to ignore this different stuff now. I'm going to go back to the original. I'm going to look for a constant ratio. So instead of taking 100 minus 400, let's divide. 100 divided by 400. Compare that to 25 divided by 100. Compare that to 6.25 divided by 25. Well, 100 divided by 400 is a fourth. 25 divided by 100 is a fourth. And 6.25 divided by 25 is also a fourth. So this ratio is constant. So this can be modeled with an exponential function. And there you go.